Okay, so what is this called? Mohammed, what is this called?
Solenoid.
It's called a solenoid, right? Very good. And why am I interested in a solenoid today? You can see that there's a magnetic field created using this compass, I would say. Today we're going to apply the electromagnet. So the electromagnet, right, is a magnet that can be turned on and off, right? And the solenoid having plenty of turns. We saw that last time, didn't we? Right-hand grip rule. If you have a wire that carries electricity, there's a magnetic field around it. Look how many wires we've got. Several wires, right? So the field can be increased. So field can be increased in few factors. Remember we said there's a current carrying wire, there's a field around it. Then there's two, there's now three. It's simple logic, isn't it? Carry on, Azan, so that's it. Larger current, very good. What else? And a soft iron core inside, yeah, very good. Or at A level, you could talk about the resistivity of the metal. It's an electromagnet, yeah? We're now going to learn a few electromagnetic devices. The bell is a beautiful one, I love it. I particularly like this one, right? So, when you do questions like this, I want you to identify the electromagnet. Quite easy, isn't it? Jonathan, where's the electromagnet? Oh. We said this is an electromagnet. What's the only resemblance, Jonathan? The red thing, right? So when I put electricity through this, it creates a magnetic field, doesn't it? This becomes magnetic field. It becomes a nice magnetic field. One other thing we said about the right-hand grip rule. This is where you flip it. We said this is the current, this is the field, yeah? When you use the solenoid, you flip it around. This is the current, this is now the field. So if the current is going like this, this will now be the field. If the current is going clockwise, like the current is going clockwise, what pole do I get here? A south pole. Did I not do this? Oh, right. Okay. Well, very, very good then. So if you take a north pole, instead of drawing it like that, I'm going to curve it a little bit and I'll put arrows at the end. Meaning, if I'm looking at the current going this way, if the current is going this way from the sides, it will be a north pole on this side. If the current is going clockwise on the opposite side, it'll be a south pole. So a little trick for you, right? If you want to know from current what kind of pole you're going to get, you do this. If the current is going clockwise, that will be a south pole. If the current is going anti-clockwise, it'll be a north pole. Nice little technique. You could use that in the exam now. Yeah? Here's our other experiment. Very, very important. Look at this. Attracts. Swap the magnetic field. What would happen then? It will also attract. What did we just learn here? Induced magnetism. Which material or which element is soft magnetic? Iron. No. Oh, soft magnetism is only iron. Okay? Iron. So these are made up of iron. So in here, can you see this wire? Touches, makes contact, right? Goes through here, goes through the electromagnet. The electromagnet is on. Guess what it's going to do to this arm? It pulls it. Can you see it pulls it? When it pulls it, because it's electromagnetic, what happens there at the contact? Look, it pulls it that way. The contact is broken. If the contact is broken, is there electricity? Is this an electromagnet now? Yeah, it is an electromagnet, but it's off. Will it now keep pulling the armature? No. So what happens? The mechanism here pulls it back. When it pulls it back, what does it do? It makes contact again, full circuit again. And this is happening really fast. And let's look at it. There you go. Increasing the voltage, bigger force. The electric bell is a beautiful demonstration to understand an electromagnet, how it works. So I'm going to give you a few today. So I've explained it. First thing, current, the circuit, the switch is on. It makes a full circuit. What happens? Current flows. What happens to the electromagnet? Turns on. What's around it now? A magnetic field. If there's iron, what will it do to the iron? It will pull it. Whatever happens, there will be impact somewhere else. For the electric bell, the hammer hits the gong. What does it do at the contact? Breaks. Incomplete circuit. There's somewhere where you could say there's a mechanism or spring that pulls it back and that makes contact again. Does that make sense? right? Okay, you can pause that now. So